Hello friends, in this video we are going to discuss some standard tools or signals of Laplace transform, and these are helps in application part. So we required these tools of a time domain function, and I listed some few functions of time domain. First one is when a function is a constant, f of t is a constant, then if you apply the Laplace transform to that a constant function, and we get the answer in frequency domain, and that is a over s. And also if you apply the Laplace transform to the exponential function e to the power at, then we get 1 over s minus a, and some trigonometric functions are there in time domain function. We convert in frequency domain. If you apply the Laplace transform to the trigonometric function, so we get sin of at is equal to 1 over a square plus a square, and also we get for cos, sine and cos hyperbolic, sine hyperbolic, and a to the t to the power n, and we discuss one by one. First one, find Laplace transform of a constant value is a. It may be in k form also, anything. So here I taken a is a constant, and that is if you apply the Laplace transform of constant, any constant, and definitely will get in the frequency domain answer is 1 over s, and this one we can prove or solve with the help of the definition of Laplace transform, and already we discussed in previous video. Solution of this one, by definition of Laplace transform, that is Laplace transform of f of t is equal to integration, and limit values are 0 to infinity e to the power minus st f of t and dt, and we get answer in frequency domain. So this is the basic definition of Laplace transform, and with the help of this one we can solve constant term. So our f of t is here given constant, where time domain function is given a. Just we have to substitute in a definition, instead of f of t just we substitute a, and after that we have to apply the integration. Therefore Laplace transform of f of t is our a constant, and integration 0 to infinity e to the power minus st, and f of t is a and dt. So a is a constant, so take outside a, integration 0 to infinity e to the power minus st and dt. In this or in here we have to apply integration, and we are already familiar with the integration terms. A is equal to integration of exponential function. So integration of e to the power minus st with respect to t, we have to integrate with respect to t. So integration of this term exponential e to the power minus st over minus s, and limit values are 0 to infinity. And when limit values are given, we have to substitute limit values, upper limit value minus lower limit, and we know, we are familiar with the properties of integration. So a is take outside and apply the upper limit in place of t, e to the power minus s into infinity over minus s, and again minus, and apply the lower limit value e to the power s into 0 minus s. In next step, look at here, e to the power minus s. Suppose any term multiple with infinity or add with infinity, then I will get infinity only. So here a e to the power minus of infinity over minus s, and here e to the power minus s into 0. Anything with multiple of 0, it means 0 only. It means e to the power 0 over minus s. In next step, look at here, e to the power minus infinity can be written a into, so 1 over, better we take minus s is a common on both sides, we take minus s also common, a to the power or a to the a over minus s, and this one can be written e to the power minus infinity can be written 1 over e to the power infinity, and minus the value of e to the power 0 is 1. So 1. And now look at here in this condition. So e is one of the positive number, and the value of e is nothing but 2 to the 2.71 something 8, and this is the positive value, and power of infinity, it means some infinity numbers, we don't know the number of the infinity, and some big amount of number, it means again we get this value is infinity only. So a minus s 1 over infinity minus 1, and now look at this condition, over 1 over infinity, it means some big amount is dividing 1, means it gradually decreases to the 0. So just we have to assume a over minus s, and this one is 0 and minus 1, and multiply with minus 1, and definitely we get a divided by s. Therefore the Laplace transform of any constant value is equal to 1 over s in the frequency domain, and this is the solution of the any constant values of f of t or time domain function. I will take one example. On, suppose find the Laplace transform of any constant value, for example 2, Laplace transform of 2, how can you convert in a frequency domain with the help of this function? So just we write 2 over s. Suppose L of Laplace transform of 3 over s, and this type, and very simple condition. So we can see any constant values of a time domain function, and suppose if we convert in a frequency domain, and we get this condition. With the help of this term we can find the constant values, and next condition will prove or we solve. and that is also very simple. Find a Laplace transform of e to the power 80, and that is Laplace transform of e to the power 80 is equal to 1 over s minus a. So, and this also with the help of the definition of Laplace transform, we can solve solution. We know that definition of Laplace transform of time domain function over this one, integration, limit values are 0 to infinity, e to the power minus st, f of t and dt. This is the definition of our Laplace transform, and here f of t is given. Our f of t function is, our time domain function is given e to the power 80. Just substitute in the definition f of t value e to the power 80 and integrate on that, and definitely you will get answer. So, Laplace transform of e to the power 80, integration 0 to infinity, e to the power minus st, and our f of t is e to the power 80 and dt. So, here take common, minus t common, so we get s minus a and t and dt. And now apply the integration of the e to the power x. So, e to the power minus of s minus a into t over minus s minus a, and 0 to infinity. So, just we have discussed previous example, when integration of e to the power something minus x with respect to dx means we can write, so integration of this term e to the power minus x or minus 1, coefficient of x is 1, and this is the integration, how to solve integral exponential function of any exponential function. So, now just I applied this condition on this one. So, now apply the upper and lower limit. So, I will take outside minus of s minus a and e to the power minus s minus a, and t is a upper limit, e to the power minus of s minus a into infinity and minus e to the power s minus of s minus a of 0. So, now again it's look here, so minus of s minus a infinity, so minus infinity, and take here minus of s minus a and upper limit value e to the power minus infinity, and here so e to the power minus of s minus a into 0, it means e to the power 0 only. So, again exponential function of e to the power minus infinity, we can write e to the power minus infinity 1 over e to the power infinity. So, again 1 over infinity, that is the value of 0. So, this one is 1 over minus of s minus a, and this one is 0, and the value of e to the power 0 is nothing but 1, and multiply with this one. So, we can write 1 over s minus a. Therefore, Laplace transform of a to the power 80 is equal to 1 over s minus a, and this is the simple solution of exponential function of e to the power 80, and we get the solution. Suppose exponential function of minus 8 is there, then just sign will be changed, and note just take a note. If exponential function of minus 80, then Laplace transform of e to the power minus 80 can be written in the frequency domain. So just formula, when e to the power positive is there and we get in negative in frequency domain, here negative, so we get s plus e. So try yourself and we'll see some examples on it. For example, how it works. Find the Laplace transform of e to the power 2t. Then we apply the second condition of or some signal, second signal e to the power 80, and which is looking like e to the power 80, and instead of a here 2 given, and we can write 1 over s minus 2. So this is nothing but 1 over s minus 2. Suppose exponential function of which is in negative minus 3t, and we get 1 over s plus 3, because here minus there, so we have to apply this condition. So we solve some examples on in next video.